Hi everyone, Bipsha this side. So in the last session, we have completed with just getting in through an understanding about how we can just take the data set in Python and then do the basic whatever the basic check. Is there any missing values? Is there any duplications we are getting in the data set, then finally doing all of the pre-processing steps, including feature engineering, scaling, everything. Then we have done the EDA, like the visualization of whatever be the features that we are using in the data set. And we have completed that part. And today, in this session, we will be just going ahead with the modeling part. So basically, this week we will be considering and going up with the supervised learning methods and forms so that things can be easily understandable by each one of you and we can just take it accordingly. Okay. So let me just share my screen and we'll start from very basic about supervised learning. We'll understand what are the types of supervised learning and how we can go with that. And we can, after EDA, how we can just go ahead, include the modeling basically, and then we can just tackle with that. Okay. So let's just go ahead. So before that, let me just share my screen. Yeah. Hopefully, my screen is visible to you people. You are able to view what is there in my screen, and also my voice is audible to you. So let's just go ahead and details about supervised learning. So you can imagine that you are learning from an efficient teacher in any of the organization or maybe in any of the college, university, whatever you can think of. Okay. So what the teacher actually do? So the teacher shows you a question like that is an input to you. The teacher shows you the answer as well. Like for this question, this should be the answer, right? And you can just learn from this pattern to predict the answers of the new question. So the similar way in machine learning, supervised learning is following the same idea. Okay, so the computer actually learns from the examples, like the input plus the output. Okay, so to make the prediction accordingly. So, in simple form, if I need to just learn about numbers, how we are adding it up, what we are doing. So, our teachers or anyone actually, when we are young, we have got down and understand the things how we can add from the teachers. So, how they have given us given us the details, right? So, they have given 2 plus 3 like that, they have given, and we have got the result accordingly. Like, okay. Now let's just give the result. 2 plus 3 like that will get the result as 5, right? So this is how I have started, like we have all have understand how we have to do the mathematics. Like the mathematics in this sense, exact summation. Again, coming down to 4, sorry, 4 plus 5. Of course, my result would be 9. So that coming down here, we have 1 plus 7, suppose. So we have got the answer as 8, right? So this is how we are just like any of our teacher are showing us this kind of example. So after learning this few examples, the teacher asks like, you have learned this, how we have to do it. Now try and do this one, right? 3 plus 6. Okay, so because we have solved some of the example, now we can get the answer of it, right? So 6 plus 3 is of course 9, right? So that this data you can see is not matching with the example that we have got. But here, what is the pattern and how we are doing the addition that we have actually learned? And we have learned it from scratch and in details so that whenever we are getting any new numbers we are able to perform the same thing because we have learned the steps that needs to be performed to do a normal calculation like addition. Okay, so that is the reason that this is how my supervised learning exactly works. Okay, so basically the key points of supervised learning that we can discuss are that is the input, there is the output, there is a training, and there is a prediction. So let me just write it. So we have the input, we have an output, we have the training, and we have the prediction. Okay, so input, what is this input? Input is the information that we are giving to our machine or computer. So it's like the numbers or features, whatever we are giving to our system. Output is the answer we want from the computer to learn. So in the initial case, we are giving like basically what we are doing, we are giving a set of information that is the input with their correct output, like as an example together. So they actually giving us a specific like setting up a example in together, right? So that this input and output set we are first giving down to our model. Okay, so model, what the model is doing, model is learning how we can do the calculations and what are the stuff that is there, the model is learning. And after that, when we are giving the model any of the unknown number, it tries to predict what would be my answer. Okay, so this is basically what my model is doing. Okay, so now coming down, what we can do here. So basically, we have understood about input. Input is the information that we are giving to our machine. Okay, so we can think about different numbers, the data, the features, basically like that. Okay, and output is the answer that we exactly want that my model should understand, and based on that, give me the output. Okay, now coming down to the training. Training is like teaching the model using these examples. Okay, what is the examples that we have given? That is based on that we are getting the answer, right? So that is the part. Next is the prediction. Prediction is when the computer or my model guesses the answer for the new input. Okay, so let's just break it into the steps. Okay, first I'll go down from very scratch so that things are easier for you to understand. So suppose I have the data like 1 plus 2. So we have the data 2 plus 3. We have the data as 6 plus 7. We have the data around 2 plus 5. We have the data 8 plus 9. We have the data around 3 plus 6, like that. Okay, so this is how my data are. So this is my labels. Oh, sorry, this is my data. Like this is the data. And now we have got the answer. 2 plus 1, 3. 3 plus 2, 5. Now 6 plus 7 is giving 15. Sorry, 13. Now 5 plus 2, 7. 8 plus 9, 17. 6 plus 3, 9. Right? So these are my data. Like this is totally giving us the examples. So this specifically the answers we are getting them as like we are calling them as labels. Okay. And together this data we are feeding to the system. Okay. So, okay, let's just go here. Okay, just a moment. Yes. Okay, let's go down to draw. Okay, fine. So suppose this is my machine. Okay. So what I am doing inside my machine, I am giving a specific input to the machine. Okay. The machine is learning from the input and trying to find the patterns, what are there inside it. Okay. So this is done. This is the training phase. Okay, so this is the training part. Like I am giving some of the input and output set. So based on the set, my model is learning. Okay, so what is this this data? So this is the example that we have discussed. This is what I am giving down to my model. Okay, and here the model is learning. Now after the model has learned, Okay, now comes the testing part. Now comes the testing part. So here what happens, we are the same model we are taking, the one that has already learned, the same model I am taking, and I am feeding it with a single input. And like input means like suppose we have got the x and the y. Okay. So 2 plus 3 is my input. And what would be my output? My output is 5. So suppose this is the example. This together is becoming the example. Okay. And x is suppose 2 plus 3 and my result is 5. So this 5 is the label. 5 is the label. Okay. Again, coming down to 2 plus 1. So this is actually giving us 3. So this is another label. Okay. Coming down to 4 plus 5. So it is giving us 9. So this is another label. Okay. So these are the labels and this thing is my examples that we are feeding down in my training set. Okay. In my model, this thing we are feeding in. Okay. Now coming down here in the testing, the same model that has learned, we are taking that model and basically here we are feeding it with X. X means like as we have taken like 2 plus 3, 2 plus 1, 4, 5, 4 plus 5 like this we are taking and we for the X we are giving 7 plus 1. Okay. So you can see here the data that we have given is 2 plus 3, 2 plus 1, 4 plus 5. But this data we haven't given 7 plus 1. So this data is totally unknown to my model, right? My model doesn't know it. So here what I'll be getting something in output, right? So what I'll be getting from the model as output, that is y. Okay, so that is basically y. So suppose 7 plus 1, the actual value of it is 8, right? So if my model understands accordingly, like learned accordingly in the training phase and in the testing phase when I am testing, it is returning me the y value equals to 8, then it's properly fine. Then my model has learned accurately. There is no issue in my model. I can take my model down for any other further analysis, right? But if there is a problem, like if suppose this is 8 is my actual red result, but my model is predicting around suppose 5. Okay, so in that case, this y predict like y dash is p, that is my predicted value that my model is predicting, and my actual value is 8. So there comes the concept of error, like okay, so there comes this concept of error that we are doing actual minus predict. So that is 8 minus 5. So that is giving me 3. So there is a difference of 3 that we are getting between my actual value. My actual value should be 8 and my model is predicting the value of 5. Right? So there is an error of 5. So the error of 3 basically. The difference is basically 3 that we are getting. So this is all about the model training and the testing. Hopefully you have got it. So in case of model, as we have discussed about supervised learning. So, supervised learning, in case of supervised learning, we have four different concepts, like the keys basically, that is the input, output, training, and prediction, right? So, here basically, in case of supervised learning, what we are doing, we are giving our model that we have just taken, that model with a set of examples that contains the problem with the accurate result of the problem. The set of such data, we are just giving it to the model. So in the training phase, what happens? The model is learning that, like getting in through about the data accurately and try to find the pattern and try to find for what reason we are getting this result. 2 plus 3, like after adding, why we are getting 5? Why not we are getting 2? Why not we are getting 3? That understanding the model is getting in the training phase. Okay. So once the model has trained, then we just need to check if my model has like trained it accurately, like learned it accurately. So for that, we are like taking a testing phase. In case of testing phase, we are giving the model with some of the unknown data and see what output it is giving us in return. Okay, so if our output matches the exact output that is the actual output, then that is fine. Then in that case, my model has learned well. There is no issue with my model. It has learned accurately. But if the model is predicting something else, in that case, there comes the concept of error, right? So this error is what? Error is basically the actual result minus the predicted result. Okay. So in that case, you can get like suppose the actual result is 8 and the predicted result that my model is giving that is 5. So we are getting an error of 8 minus 5 that is 3. So there is an error of 3 that we are getting. Okay. So this is all about the supervised learning. Hope you have understood about it. Right. Now coming down to the two main types of supervised learning. So let's discuss about it. Types of supervised learning. Okay. So basically, we are getting here the very first one is regression, and the second one we are getting that is classification. Okay, so the regression is basically it predicts the numbers, and we are predicting a continuous number. Okay, it predicts the continuous number. Like suppose we are talking about, like suppose we are giving the input as a house size. So in my output, I want the price of the house. Okay, so this is basically the regression. We'll discuss about regression in details. This is just for a reference, like what are the types and what are exactly they doing. So that is for that. So we'll go down in regression in details and understand how we have done it and what are the mathematical logic that is there inside it. Coming down to classification. Classification, it actually predicts the category or the group. Okay, like if I need to give you an example, I'll call about the email text, right? So suppose there is a text in the email that I have given. So in return, I'll get the output if the mail is spam or not spam. Okay. So if suppose the question like if suppose the mail is saying if the email says around say like when like 10,000 or 1 lakh now, so we can easily predict that this is a spam kind of email that we have got, right? So same kind of we can get about the regression, but regression in that case we are predicting numbers, not the groups or the categories. So in input, if we are giving so like the house size, like if we are telling the house size is 1,200, like 1,200 square feet, sorry, square feet, what would be the price? In that case, my model will predict what is the price of the house. Okay, so this is regression. Now, how this supervised model actually learn, right? So, just giving you some of the reference so that you can just understand. Then we will be just going down. So, like how supervised learning like works actually. Supervised learning working. So, basically, first step is collecting the data. Suppose we have the data like temperature, and then we have the suppose the ice cream sold. Okay, so we have the data accurately, the temperature and the ice cream sold. So if the temperature is suppose 30, the ice cream sold is around like the amount is around 50. If the temperature is 35, it is around suppose 60. And if this temperature is 40, we are getting it around 80. Okay. So this is how my data is. So the temperature is, this one is the input. This one is the input. And this one is the output. Okay. So this is the input and this is the output. So this is my data that we need to collect, right? Next, we need to train the model. The next step is to train the model. So what happens, like suppose in case of training the model, we are showing this examples to my model, and my model tries to find the pattern. Oh, like it's like finding, oh, in that case, if the temperature increase, the sold of ice cream also increases. So when it's hotter, more ice cream is being sold. So this kind of like somewhat idea we will be getting after training the model, because the model will try to find the pattern. So here you can see the pattern. If the temperature increases, the number of ice cream that is sold, or the amount of amount is also increasing, right? You can understand by it. So this is the model training. So from this data, the model is training, right? Now coming down to the prediction part. So, like, suppose you are asking to the model, like, today is around, the temperature is suppose 37 degrees. So, how many ice cream will get sold? Okay. So, the computer basically, we are telling just for making you understand, basically, my model. So, the model actually tries to find the pattern there in the training set, and it tries to utilize that understanding here in the prediction phase. So my model actually uses the pattern that it has learned and predict that around, maybe if the temperature, like if the temperature is around in between 35 to 40, that is 37, the number of ice cream sold would be around, suppose, about 70, because you can see that 30 is, if the temperature is 30, the ice cream sold is 50. If it is 35, it is 60. And if it is in between 35 to 40, around 37, in that case we'll get a number in between, right? So we'll get it around 70. Okay. So this is the way we are getting it. Okay. Now, this is the way we are getting the things done. So this is called the supervised learning, because there is a, like always a correct answer that is already given to the model in the training phase. So based on the input and output paired, my model is learning first. Once it has completed the learning, then we are going down to the testing phase. In testing phase, what we are doing, we are giving the model a completely new data without the output. We are just giving the input, and based on the input, we are getting a specific output. If our output matches with the actual result, then it's fine. That means my model has learned accurately. If it couldn't, then there should be like there should be a difference, right? That there comes the concept of error. That if what is the error? By what error my model is unable to predict it? Okay, so that is the part of supervised learning. Okay, hopefully supervised learning is pretty much clear to you, like how we have to do it and what are the process and what are the steps. I have tried to explain you from scratch, from the initial level, so that you can understand it in a better way. Now we'll just move it down to the types of the supervised learning. The very first one is regression. Okay, so regression will first, like inside regression, there are two other types, that is linear regression and multiple linear regression. Okay, so there is other type as well, that is the logistic regression that comes under classification type. So for today, we'll try to just take it to the linear regression. That is the simple one, easy for you to understand, and eventually we will be moving ahead. Okay, so let's just take it to linear regression. So linear regression is basically like what is the problem we are trying to solve, right? So first we let's just take an example so that things can be easily understandable. So in that case, just think like suppose if you know the size of the house, can you predict the size of the price of the house? That would be the question that we will be answering. So for example, suppose you have a small house, the cost of the house would be less, and if you are having a big house, the cost of the house would be more, right? The money would be cost more money, right? This is what. So now you want to learn, like based on this, you need to prepare this regression. So what basically is regression, right? Regression means is like guessing a number, like guessing the marks, guessing the price of the house, guessing the height, guessing the salary, where we can guess the details accordingly, like the house price, the height, the marks, based on the examples or based on the given data. Okay, so what is now coming down to this part, that linear regression is comprising of two words, linear plus regression. Okay, so as I mentioned, what is regression? Regression is like guessing a number, like guessing a mark, guessing price, guessing height, guessing salary, all of it like that. And what does linear mean? Linear is like straight line. Linear means straight line. So linear regression is like guessing the numbers that we are using as a straight line, right? So that is the part. So let's just look at the data, and based on that, let's try to get the details accurately. Okay. So let's have this house size, and we have this price. Okay, so about the house size, let's take it as around 500 square feet, 1,000 square feet, coming down to 1,500 square feet, and coming down to 2,000 square feet. Okay. Now the size of the price, we like the price wise, it is coming around 20 lakh, coming down to 1,000 square feet, that is going to 40 lakh. Next 1,500, that is going around 60 lakhs. For 2,000 square feet, that is coming around 80 lakhs. Okay. So this is my data. This is my data for training my model. So this data I'll fit down to the model. Okay. Now we need to draw a graph that will be giving us a like the graphical rule of house size, and like along x-axis and y-axis. So basically, like let's my data, let's just take it here. Okay, fine. Let's just go here. Yeah, fine. Control V. So it has got me here. So just a moment. Fine. Let's just take another one because we are getting an issue up here. So this is the house size and the price. Okay. Now let's just take an, okay, fine. Let's take this one and we'll just plot it down. Okay. So this is along x-axis, this is y-axis. So along x-axis, we are taking the house size. This we are taking as house size. And this here, we are taking it around y, we are taking as the price. Okay, so suppose this is around 500, this is 1,000, this is 1,500, this is around 2,000. Okay, so this is my plot that we have done. And for here, this is 20, this is 40, this is 60, and this is 80, right? So for this, if we are getting for the first one, that my plot will be here. So this is my plot. Coming down to 1,000 with 40. So this would be my plot. This would be my area where I'll be plotting. Coming down for this would be my plot area, that this is my plot. And also about this would be my area that will be plot. Okay, so you can see that I can draw a straight line that will just connect all of it accordingly, right? So, like maybe not all, if this point is outside, like majority point will be connecting like that. Okay, so we can connect the dots that will make this straight line. We can say it. Okay. And the straight line is this linear regression. The straight line that we have drawn, that is the linear regression. Now coming down to the formula. So this formula of straight line, all of you know what is the formula of straight line? Y equals to mx plus c. Okay. So y equals to mx plus c. Now, what is this y? Y is the house price because along y is would be this house price because along y axis we have taken the price. So y is my house price. Now coming down to x, what is x? X is my house size. So along x we have taken house size. So along x we are getting the house size. So what we are already knowing that we are needing to put in x because x is the independent variable. Independent variable. And y is the dependent variable because based on the value of x, y is actually depending. Based on the house size, we are predicting the price, right? So that's why we are getting it like that. So y equals to mx plus b or c or whatever you want to put, that will be good to go. So x is basically the independent variable. So that is the house size and y is the dependent variable that is going down to the house price. Okay. So now coming down to M, what is M? M is like how fast the price is increasing that we are getting by the value of M. So M is basically the coefficient of X that is actually predicting this. M is giving us how fast the price is increasing. Like from 20 to 40, if the house size is increasing around 500 square feet, if it is increasing, in that case the house of the price is increasing around 20 20 lakhs, right? Now if this value is again changing with 500, there is a change in the value again 20. Again if that is changing to 500, then there is a again change of 20 lakhs, right? So for every 500 square feet, there is a change in the price of 20 lakh that we are getting up here. So as we have got y equals to mx plus b. So b is the, what is b? B is the starting price. B is the starting price and m is how fast the price is increasing. So this is my formula y equals to mx plus b. Okay, now we need to understand about M. So what is M? M, we already mentioned how fast the price is increasing. So M is basically my slope. Okay, now you can see here the price by, like as we have discussed from our data, we are getting the size increase of 500 square feet. The price is increasing by 20 lakhs, right? So if it is 500 square feet, the value that is increasing, that is around 20 lakhs, right? So this is the details that we have got. Now, M, what is M? M is equal to 200 by 500. 20 by 500. I'm really sorry, 20 by 500 because that we have taken it around lakhs. So 20 would be in the numerator and 500 that we will be getting here. So mx, generally how we are getting it? So we are getting y equals to mx plus b. Now in any case, b equals to 0. In that case, we are getting y equals to mx, right? That we are getting. Now in that case, if I need to find m, m equals to y by x. right? M equals to y by x. And y here, as we have taken, y here is the price and x equals to the size. So we are taking m equal to 20 by 500, right? Because we are getting it now. If we are cancelling 0 and 0, 2 divided by 50, that is giving us 25. So our result value of m equals to 1 by 25. Right? So 1 by 25 is 0.0.04. Okay. So the value we are getting as 0.04. So that means like for every square feet, like for 1 square feet, the price is increasing around 0.04 lakh. Okay. Suppose the value is increasing like here 501 square feet, if this is 501 square feet, then the value would be 20.04 lakhs. Okay, because for every 1 square feet, the value is 0.04 lakhs. Okay, so this is how we have calculated the m, that is the slope. Now coming down for b is basically the intercept. Okay, now basically what is happening up here? Here this b actually means like the price when the house size is 0. Okay, b is the price when the house size is equal to 0. Okay, so, like even before building the house, there is a land value, right? So, from the data, the line starts from 0 price when the size is 0. Okay, so when b equal to 0, right? When b is equal to 0, we are getting the price p, that is equal to 0.04 into size, like the house size, like basically this portion, y equal to mx. So as I mentioned, y equal to mx plus c, or else b, to be very one. Now if b equal to 0, we are getting y equal to mx, right? We are getting y equal to mx. So y is the price. M we have already got the value as 0.04, and x would be the house, like why we need to predict basically. M is 0.04 and x, what is x? X is the house size. So of course we know the house size. So if we are knowing the house size, so just a moment. If we are knowing this house size, uh, around suppose 1000, in that case we have already got the value for 1000. So let's take it around 1200. In that case, in when the value of b is 0, in that case what will be the value? Well, what will be the price? In that case my price will be 0.04 into 1200, right? So it will be giving us in the denominator 100. So this will be deducted automatically. So 12 into 4 is equal to 48. Okay. So we are getting the value as 48 lakhs. Now, if we are going up here, you can see we have got the value as 1000 for 1000 square feet. We have got the value as 40, and 1500 we have got the value as 60. Like, so if the value of b, only case if the value of b is 0, in that case we are getting the value for 1200 square feet, the value we are getting as 48 lakhs. Okay, that is coming in between of 1000 to 1500 square feet, that is 40 and 60. Okay, so this is how we are getting the data. Now we have to take it like we need to predict the price accordingly. So we have predicted this price as 43. So this is all about the linear regression that we have discussed. So why do we need linear regression? Because we don't know the price of the house accordingly. We learned the old data and we tried to predict the price of a new house about whose square feet, like house size is around 1200, right? So that needs to be taken it accordingly. So now, how does this like this model actually learns it? So it first draws the lines, it checks how wrong it is, adjusts the line and repeat it the same time. So this is actually the training part that we are getting. Okay. So this is all about the details that we have got. So now I want to discuss about how does it reduces the error. Like suppose, let's take it. So here you can see that basically suppose my actual value based on the data we have got for suppose 1200. Okay, just a moment. 1200 square feet. We have got this actual value that is around 50. Okay, 50 lakhs. But my model has predicted around 48. Okay, so what is the error that we are getting? So 50 minus 48, that is 2. There is a difference of 2 lakhs, right? That we are getting. So how does it like how we can just reduce the error? So if we are changing, because my formula equals to y equals to mx plus b, so here you can see why we are predicting x value would be what we want. Like this we can't change, right? So if we are changing the square like this value, then that would be a difficult. I want the like I want the house price for 1200 square feet house area or house size, right? So in that case, I have the value of m and I have the value of b. So I can just change that to take it accordingly. Okay, it like if we are changing the value of m, that is slope, and b being the starting price, we can just change it accordingly. So little by little change in the line fit the lines the best. Okay, so this process is called gradient descent. This process is called the gradient descent. So this is all about the details that we have discussed. Now take it down to the Excel and let's again discuss with the data how we have gone ahead with. Okay. Suppose we have added one more around 2500 and we have taken the value as 100. Okay. Now what is basically our goal here? Here, our basic goal is we need to just take it accordingly y equals to mx plus b, this part. Okay, so we want to find the best straight line for this data set. We want to find the best fitted straight line. So m, I told you, m is the slope, like how fast the price is increasing, and b is the intercept, that is the starting price. Now again, we need to calculate the formula of the slope. So what is the formula of the slope? So that is m equal to n summation. So this is the numerator. Okay. So n summation x comma y, like xy basically, and that would be subtracted with sum of x into sum of y. Okay, so this comes the numerator section, and now we have the denominator. So denominator is sum, and sum is about x square. Okay, so we are doing the sum of x square that we are doing, and then we are subtracting that. We are subtracting that with summation of x and the square of it. Okay, just a moment. Yes, the square of it. Yeah. So this is the formula of M. Okay, let's just do it one by one so we'll be able to understand it. So house price, this is of course X, and this is price, so this is my Y. Now we need to get it through with X square, because here we will be needing X square. So we need to just do the x square. So for this, my values would be 250,000, like 25, 2,50,000 that we are getting here. Next, we are getting the value of this 1, 2, 3, 4, 5, 6. 6 zeros would be there. Okay. So for 15, it is 225 and 4 zeros. For this, we are getting around 4 with 6 times zeros. And for this, we are getting 625 with 4 times 0. Right? So this is the value of x square. Now we need to calculate x into y. So xy, that is 500 into 20. 5 twos are 10 with 3 zeros extra. Now coming down for this. So this 4 with 4 zeros. Okay, sorry, 4 zeros. This would be 9 with 4 zero. And this would be 16 with 4 zero. And this is coming up 25 with 4 zero. Okay. So we have got the house size as x, price as y, x square, the value of x square accordingly, and xy values like this. Okay. Now we need to get the totals because here basically we need the summations. So if I need the summation of this, so I'll just use sum and I'll be summing it off. We have got the sum like this. Yes. So we have got all of the sum of x, sum of y, sum of x square, sum of xy. All of it we have done. And the value of n would be 5, right? Because here we are getting like 5 values, like 1, 2, 3, 4, 5. So 5 input output pairs we are getting up here. So the value of n is 5. Okay. Now in the numerator, what we need to do? We need to do summation xy, n into summation of xy minus sum of x and sum of y. So we will be doing here 5 into 5 into 55, like 5,50,000. This we need to do, like this one we need to do. So if we are doing 5 into 5 with 4 zeros, so my result would be of course 275 with 4 zero, right? And if we are doing this, like next we have to do sum of x and sum of y. So 7,500 and 300 that we need to do. So if we are doing 7,500 and we are just multiplying it with 300, we are getting the value that is coming up around 225 with 4 zeros. 225 with 4 zeros. Yes. So now if we are doing the subtraction of it, that is giving us as 5 with 5 zeros, right? So it is giving us the result as 5 with 5 zero. Now coming down for the denominator part, denominator is n sum of x square minus x sum of x and the square of it. Okay. Now here basically we need to do 5 into this. So that would be giving us 6,875 with 4 zeros, and we are doing sum of this and this one with a square. 7,500, the square of 7,500, that is giving us the value as 625 with 4 zeros. Okay. So this is the result that we are getting as 125. We are getting the result as 12500. So one, two, three, four, four zeros that would be there. One, two, three, four, five, five zeros would be there. Yes. So 125 with five zeros we will be getting up here. One, two, three, four, five. Yes, right. So this is the values that I'll be getting by subtracting this. Okay. Now basically I need to calculate, like this is done. We have got this value and we have got this value. Now basically we need to do 5 with 5 times 0, 1, 2, 3, 4, 5 divided by 1 to 5, 5 times 5, 5 times 0. Okay, 1, 2, 3, 4, 5. Yes. So this would be giving me the result as 0.04. Okay. So this is the result that we will be getting from this. So this is how I need to calculate M. Now how I need to calculate B. So for calculating B, basically I need to do summation of y minus M summation of x, and that this is in the numerator and divided by n that we need to do. So this is basically summation of y. So this is coming up with 300. So we are giving it here 300. So here let's put the value as b. So 300 we are getting minus the value of m is 0.04 and summation of x is this one. So 0.04 into 7500, that is giving us 300. B equals to 300 minus 300 divided by 5. It is giving. So the value of B at the end we are getting as 0. Okay. So the intercept we are getting as 0. So the final linear regression result, the line that needs to be fit in, that is coming equals to y equals to 0.04 x plus 0. Okay, so this is how we are getting the value. Now, now if I need to predict the new house price where the size of the house is around 1,800. Okay, so in that case, for the price, what I need to do for the price, I just need to include 0.04 into 1800. So that is coming around 72. Okay. So for any of the price that we are getting, the value is like in between them. That is 1,800. The value is coming around 72 lakhs. Okay. So here you can see for this 1,500, the price we are getting as 60, and for 2,000, the price is getting up around 80. Now, any of the price in between them, that is 1,800, that is in between 1,500 to 2,000, the value we are getting that is 72 lakhs. Okay, so this is how we are getting. Now we need to check for the error. Okay, so for checking the error, like in that case, this is optional, but basically it is required. So for checking the error, suppose for 500, the square feet, 500 square feet, the actual price what we have got that is 50. Sorry, 60. So for 1,500 square feet, the value that is the actual value that we are getting that is 60, right? But in case of prediction, suppose for prediction, what we will be getting? So we will be getting 0.04 into 1500, right? So that we are getting, and the value is 60. Okay. Now here the error basically that we are getting that is 60 minus 60. So that is 0. So there is no error. So my model has learned accurately. There is no issues with the part. So why the fit is perfect here in this case, if I need to tell you, because the data is increasing evenly, and for every 500 square feet we are getting a exact 20 lakhs. The price is increasing. All the points lies exactly on the straight line. That's why we are getting a much accurate and result, and also there is zero error. So that means my model is predicting everything near perfect. Like everything is perfect up here. At least for this value, we have got the value correctly. Like the prediction was correct. Okay, so this is all about the linear regression. So this is how we have to take it through about the linear regression in details. We have explained regression, supervised learning with linear regression in details. Next, we will be moving down for the multiple linear regression. Okay, so multiple linear regression. So earlier we have predicted the house price using only one thing, that is the house size, right? But in real life, you can understand that house price doesn't only depend on the size of the house. There are other factors as well that affect the house price. Okay, so that is the size of the house. That is a major criteria. Coming down, the how many rooms or how many bedrooms are there inside the house. What is the location? What is the distance from the school? Maybe what is the parking available? Like is there any proper parking area available or not? That all many of this input affect one single output, right? So that is the multiple linear regression that is coming up here, that we need to understand. Okay, suppose we have to take a data set based on that, and based on that we need to understand how the things are moving. So here you can see for this a data set, we have only one x, and y value will be of course 1, but there is only one factor that it has affected. So that's why the formula for linear has came up according y equals to mx plus c or b. Okay, so but in case of multiple linear regression, the formula would come up equal to y equal to b plus m1 x1 plus m2 x2 plus m3 x3. Like this it will be moving. So meaning for each part we are getting like more than one input variable we are getting. So here y is the house price, b is like the best price, like the starting price, you can say, like the base price that we can see. Coming down to x1, x1 is again the, suppose like any of the independent variable, we can take here the house size. X2 is maybe the rooms in the house that we will be getting. X3 is the distance from the city, like that we will be getting. And M1, M2, M3 is like the effect of size. M2 would be the effect of bedroom. M3 is like the effect of distance. This all we are getting up here. Okay. So the same thing, the same process, same everything, but here we are getting more than one independent variable against one single dependent variable. Okay. So next time when we will be getting in through, in that case, the house price would be predicted likewise. Okay. Suppose in that case, if I am telling you, like if we are going ahead and taking an example, suppose we have taken the house size, sorry, okay. So house size we are taking bedrooms available. Next we are taking suppose distance, and we are taking the price. Okay. So coming down to the house size, so it is 500 going down to 1000, next 1500, next coming down to 2000, next coming down to 2500. Okay. So suppose the bedrooms, okay, the spelling is wrong. Okay. Coming down here, we have 1, 2, 3, 4, 5 like this. And the distance we have to take, let's take as 10 kilometer, 8 kilometer, 6 kilometer, 4 kilometer, 2 kilometer. That and price we can take 20, 40, 60, 80 and 100. Okay. So this is the data set with the values. So this is basically x1. This is basically x2. This is basically x3. And this is of course y. Okay. Now we need to find what are the inputs and the outputs. So, like as we have already discussed, now we will move down for multiple linear regression. We have already discussed the formula. Now coming down to the forms. Okay, so suppose after training, let's just assume, just for an assumption, like as you know how to get the values accordingly, the value of m and value of b, the same way you need to calculate here. So here basically after calculation you get the value like this. Suppose the value of B is 5, the value of M1 is 0.03x1 plus suppose 5x2 you are getting plus or minus you are getting 2x3. Okay, so this is the equation. After training, the model actually find this equation. So after after this part is done, so we need to predict the new house. Okay, so new house with size around 1800, coming down to bedrooms. That is going 3 bedrooms we have got, and the distance that is 5 kilometer. Okay. Now we just need to put the values accordingly. So y would be equal to 5, that is the value of b, plus 0.03 into we need to do 1800. So there would be a bracket, plus we need to do 5 into 3, plus we need to basically minus, because the result here we have taken as minus. So minus we have taken 2 into 5. Okay. So this we have done. So after calculating, it is coming 5 plus 54 plus 15 minus 10. So we are getting the value of y, that is equals to 64. Okay. So the predicted price for this is around 64 lakhs. Okay. So here you can see that why there is this minus sign. You can like you sorry. So why there is this minus size? Because the bigger distance is lesser in demand, right? So we have taken the distance around 5. So we like the when the till the distance from the from the place you are staying or the house you are having, the distance of the city is around 5 kilometers, right? So there is the distance might be this is the issue basically. So bigger the distance, lesser would be the demand and lower would be the price. Okay. So we have taken minus 2x3, like that we have taken it. Okay. So this is how you need to do it accordingly. Also here also the same error will be there. So error you need to calculate, that is the actual price minus the predict price. So the model actually tries to make the total errors as small as possible. What is the total that it tries to make it possible so that we are getting it accurately. Okay. So this is all about the regression part, the linear regression and the multiple regression. Okay. So next day we will be continuing from here and we will be taking it down from here. And based on that, we will be understanding when we will be plotting that up in the graph, or like we are sorry, basically when we will be plotting that and seeing how the data is aligned, and based on that, we'll try to do the linear regression, like how we are training the linear regression model and this multiple linear regression model we will be understanding in the collab file. Okay, so that based on that we can just take it accordingly. Okay, after that is done, we will be moving down with the classification models. Okay. So, okay, guys, so we can connect in the next session, and hopefully, you have understood each and everything in details in today's session. We'll connect in the next session, and accordingly, we will be just taking it accordingly. Okay, so thank you everyone for joining today's session. We'll connect in the next session, of course, and accordingly, we will be moving in. Okay, so thank you, guys. Bye.